welcome to another episode of Silence Abounds, Science at Home, where we're going to discover home lab magic. Welcome to the channel. If you're new to the channel, I demonstrate scientific principles, reactions, and concepts through experiments that I perform in my home lab. I cover chemistry, biology, microbiology, microscopy, and molecular biology. In today's episode, I'm going to demonstrate the technique called Iodometric Redox Titration. And we're going to use this titration to determine the percent concentration of chlorine in household bleach. Please check out my previous video that I did dedicated to acid-base titrations, where I went into more detail on the technique of titration. Using iodometric redox titration, we're going to use sodium hypochlorite, which is a strong oxidizing agent. We're going to measure sodium hypochlorite, which is bleach, and in an acid medium, hypochlorite oxidizes iodide ions to form iodine. This liberated iodine is then titrated with a standard solution of sodium thiosulfate. The amount of thiosulfate used is directly proportional to the chlorine content. In this titration, we also use a starch indicator. Starch indicator is widely used in iodometric titrations because it forms an intense blue complex with iodine, allowing for a very clear detection of the endpoint. Iodine molecules enter the helical structure of amylose, one of the components of starch. This inclusion forms a charge transfer complex that produces the characteristic dark blue color. So let's go ahead and perform the titration. Okay, so first thing I'm going to do is measure the flask that I'm going to measure the quantity of bleach that I'm going to use. So I don't have a 100 ml volumetric flask, so I'm going to use as accurate as I can. So I'm just going to use a measuring cylinder. So I'm going to measure the weight of the cylinder, and I've got a log that I'm going to record any of my values that I need to help with my calculations. So the weight is 118.7 grams. And then I'm going to add 100 mLs of my chlorine, and then I'm going to weigh that again. Okay, so I've got my bleach container here, and I'm going to pour as accurately as I can 100 mLs. Okay, for the final part, I'm just going to get a pipette and transfer. So I make it to the line of 100 mLs. Because this is going to help calculate the density of bleach. And that's going to be important for my calculations later. So I'm just going to add a little bit more, and I should be at the 100 mark. Okay, so now what I'm going to do is I'm going to measure or weigh that. Again on my balance. And it is 2 to 5.9 grams. So I'm going to record that on my log. So next, what I want to do is I want to weigh 2 grams of potassium iodide. So I'm going to tear my balance, and then I'm going to measure out 2 grams into a conical flask. And then I'm going to add 25 mLs of water to dissolve. Okay, I've got 2 grams of potassium iodide, and I'm going to add 25 mLs of water. Let's take that away. Okay, so 25 mLs of water to dissolve. Okay. Okay, so now I need to mix that, and I'll allow the potassium iodide to dissolve, and it should be very soluble and very quick to dissolve, which it has. So now that I've got my potassium iodide, what I want to do is I want to create an acidic medium environment. So I'm going to add transfer about 5 mLs of acetic acid, glacial acetic acid. So I have a measuring cylinder here, and I'm going to measure 5 mLs of acetic acid. I'm going to again use a pipette for the final addition because, I want to keep it as accurate as I can. Okay, so I've got 5 mLs of acetic acid. So I'm going to add that to the conical flask, and this creates the acidic environment for the reaction to occur. Give that a mix. And now I'm going to add 2 mLs of my bleach into the conical flask. I have my bleach here, and I'm going to use the same measuring cylinder I just used for my glacial acetic acid, and I'm going to measure out 2 mLs. Again, I want it as accurate as I can. That's 2 mLs. And when I add the bleach to the flask, the solution is immediately going to turn dark brown as the chlorine bleach oxidizes the iodide ions to the free iodine. Okay, so the free iodine has now been liberated. Okay, it's the typical expected color of iodine, as you can see. So now what I'm going to do is prepare my burette. I don't need the bleach anymore. So now I'm going to prepare my burette, and I've got a solution that I made up a 0.1 mole sodium thiosulfate, and that's going to be my titrant. So I'm going to add that to my burette. Okay, so I've added it to my burette. And what I want to do is I want to zero my burette to a starting point. So I'm just going to drain some of this. There we go. And then what I want to do is I want to bring the level of my thiosulfate to the meniscus. Okay, so I'm going to start at mark 7. So I'm just going to record that. That's the starting mark is 7. So what I'm going to do is I'm going to get my iodine flask. And what I want to do is I want to titrate or add my titrant until the brown color goes to a very pale brown. And then I'm going to add my starch indicator. So I'm going to start and add my titrant now. All the while, keep mixing it. And I'm looking for the color change to go to a pale brown. You can already see the color going paler. All right, so now what I'm going to do is I'm going to add 2 mLs of my starch indicator. So I have a solution of, it's just the starch indicator I made up using cornstarch in water, boiling it until I get a clear solution, and that will serve as my starch indicator. So what I'm going to do is I'm going to add 2 mLs of the starch. Let me just measure it out in a measuring cylinder. And it's going to immediately take on an intense blue-black color due to the formation of the starch iodine complex. Okay. So now what I want to do is I want to continue adding my titrant until this color disappears and it goes colorless. So when it starts to go colorless or the color is fading, you want to add your titrant very slowly, drop by drop, because you want an accurate as a result as possible. So I'm very close to the end point. So I'm just adding my titrant very slowly in small amounts, because as soon as the endpoint is reached, it will immediately turn colorless. And I'm almost there. just add one more. And it's gone. Just add one more just to make sure. Yeah. Okay, and now it's gone colorless. I have reached my endpoint. I'm just going to add a little bit more just to, what I'm going to do is read how much I've added. So it's 56.8 I've added. So it's 46.8. Okay, so I've reached my endpoint. So now I have everything I need to perform the calculation to calculate the percent chlorine that is in my household bleach. So let's do that now. Okay, so here are all my notes and calculations. So the first thing we want to do is calculate the density. And we do that by taking the mass of the bleach, which is 107.2 grams, and divide that by 100 mLs. And that gives us a density of 1.072 grams per ml. Next, we want to calculate the moles of sodium thiosulfate using 0.1 mole solution. So the final volume used was 39.9 mLs. So we take that and convert that to liters and times that by the mole of 0.1. So it's 0.1 moles per liter times 0.0398 liters of titrant added equals 0.0039 moles. Next, we want to calculate the moles of sodium hypochlorite based on a 1:2 stoichiometric ratio in the reaction. 1 mole of molecular iodine reacts with 2 moles of sodium thiosulfate to produce 2 moles of iodide ions. So we take the moles of sodium thiosulfate used, which is 0.00398 moles, and divide by 2, and that equals 0.00199 moles of sodium hypochlorite. Next, we need to calculate the mass of sodium hypochlorite using the molar mass 74.44 grams per mole. So we take J result, which is 0.0019 moles, and times that by the molar mass, which is 74.44 grams per mole, and that gives us a molar mass of 0.148 grams. We then need to determine the mass of sample, which is calculated by volume times density, which is we used 2 mLs of the bleach, which is so 2.00 mils times the density, which is 1.072 grams per ml, gives us a mass of sample of 2.144 grams. So finally, we can calculate the mass percentage, and this is calculated by dividing the mass of the solute by the mass of the total sample. So we take 0.148 grams divided by 2.144 grams times 100 gives us a percent concentration of bleach or sodium hypochlorite as 6.9%. typical household bleach has anywhere between 3 to 8% of sodium hypochlorite. So we are well within the range of concentration. So our household concentration was 6.9%, which is an acceptable result. Well, I hope you enjoyed that demonstration of an iodometric redox titration. There are many applications for this type of titration. Obviously, what we demonstrated today, the determination of available chlorine in bleach, can be used to titrate chlorine and determine how much chlorine there is in pool water. It's also used in the analysis of water detergents, disinfectants, in the determination of oxidizing agents in analytical chemistry, for example, copper-2 salts, potassium dichromate. It's used in the food and beverage industry for measuring vitamin C content in fruits and juices and determining sulfite preservatives in wines. Well, I hope you enjoyed that video. If you did, please hit the subscribe button. It's free and it means a lot to me. It supports the channel. Hit the like and share button. Spread the word. It truly, truly means a lot to me and to see everyone's support. Please feel free to leave me a comment. I love to hear your feedback. Any questions, you can send me an email as well. If you want a video notes that accompany this video with the scientific information behind the video, please feel free to send me an email and I will be happy to send those notes to you for free. Until next time, keep on experimenting. Goodbye, everybody.